Good afternoon, everyone. Welcome back to Tech Talk Tuesday here at Treadwell. Edward Titley's my name, and today we're having a discussion around dissimilar metals. So, just before we get started, a couple of things. Firstly, thanks for joining, and if you're new, welcome, and if you've joined us before, welcome back. We run these sessions typically fortnightly, aim to be about 15 minutes or thereabouts, and we discuss a topic that's typically been suggested by one of our attendees of something they'd like us to cover. So today we're looking at dissimilar metals. We'll have a Q&A session at the end, but I've got the Q&A window open now, so feel free to drop anything in that chat as we go. And if you've got any feedback, good, bad, or ugly, if the session was worthwhile, we'd love to know. If the session was a waste of time, we'd like to know that too. And if there's a topic you'd like us to discuss or go over in future, please also send that through. Always looking for content ideas and always looking for suggestions. We want these to offer value. So with that said, we'll get straight into it. So dissimilar metals. Firstly, what are dissimilar metals? A lot of us have probably heard the term. We might not be quite sure what they are or why we care about them or what concerns or problems they might present. So firstly, dissimilar metals are metals or alloys with widely different properties. When dissimilar metals contact each other in the presence of moisture, which can include the moisture in the air, galvanic corrosion may result, which can weaken the parts, premature failure, or other corrosion control requirements are therefore needed to be put in place. So, types of dissimilar metals risks. Firstly, is galvanic corrosion we've mentioned. When dissimilar metals come into contact in the presence of electrolyte like moisture or in the air, or salt water is even worse, or some other substances, they can effectively create a small electrical circuit which leads to galvanic corrosion, which is typically accelerated over corrosion that we would normally see for something just in normal use. The other potential concern is differential expansion risk, where dissimilar metals potentially expanding and contracting at different rates, which can cause some challenges or concerns around connections where they're connected to one another. But really, mainly what we're focusing on today is the galvanic corrosion aspect. So where might we see these crevice corrosions? So tight spaces or gaps between dissimilar metals might be a flange and a blank plate on a pipe, or a flange made of one material and a pipe made of another material. It could be a stainless fixing into a mild steel structure. It could be an aluminium handrail on a mild steel structure. There's a variety of places where we often run into these situations and potentially overlook the concern that we might cause ourselves down the track. So we'll see accelerated corrosion, which obviously is not good from a maintenance perspective, but it's also not good from a structural perspective. You don't want to see stress corrosion cracking or something like that. So why are we worried about this? Firstly, is the maintenance aspect. Obviously, here at Treadwell, we're interested in low maintenance structures. I won't say no maintenance because I don't think any structure exists that's zero maintenance, but low maintenance structures. If we've got galvanic corrosion, regular inspections, cleaning, recoating, cathodic protection, sometimes we might have isolation coatings or rubber isolator packers or washers or something like that. We need to inspect and make sure they're still present, not in any way deteriorated or perished or decayed, and then the associated cost to fix that. Premature failure is another part of that if we're not getting the service life that we want to get out of things. But then also disruption to operations. If we've got a processing plant or an area that's out of service, or a sewage treatment plant or something like that that's out of service, that's obviously problematic as well. So we want to reduce the maintenance we have to do on any structure, whether it's FRP. I mean, obviously, we've got I guess, a bit of a bias towards that, as you might imagine, but any structure really. Now, high risk environments, especially salt water, seems to accelerate galvanic corrosion. I guess salt water is a better electrolyte. Often we'd associate with that with maritime, offshore, jetties, wharves, those sort of things, but also a lot of mine process, mineral processing, a lot of the water used is very saline. So that's another area where we see accelerated galvanic corrosion. One thing I also want to point out is a lot of these areas have limited access. So scaffolding costs, EWP costs, rope access. It's all an unnecessary expense. Same with water and wastewater treatment, hydrogen sulfide, chlorine treatment chemicals, typically high humidity, constant exposure to moisture and so on, and multiple metal types. We've mentioned some of these situations where we might see these. Often we see a mild steel structure with a coating, which is fine. We might try and put an aluminium handrail on it. We might hang a stainless steel cable ladder from it. All these interfaces are potential starting points, I guess, for corrosion from a galvanic corrosion perspective. So how or why does FRP help? Most commonly used, we've touched on, is an isolation, so a physical barrier between parts. That might be rubber packers, it might be nylon or rubber washers, it might be a coating to try and keep those parts separated, or it might be corrosion control measures, blast and paint. It could be a cathodic protection system. There's a variety of ways it can be done. How or why does FRP help? FRP is obviously non-conductive. So we've mentioned a mild steel structure with the stainless cable ladder, stainless handrail, aluminium handrail. Question this brings is, where do we do the isolation? This is often a discussion we have. If I've got a mild steel structure, you can imagine I want to hang a stainless cable ladder from it. Where do I do the isolation? If I've got a mild steel structure that's epoxy coated, do I do stainless threaded rod or a trapeze type bracket to hang it from, and thereby have to isolate the stainless threaded rod, say, from the mild steel structure? Do I do a galvanized threaded rod, which may not have the durability of the epoxy coated structure, and then isolate on the cable ladder? So there's a lot of considerations. If we go FRP, and obviously FRP is not right for everything, but if we go FRP for, say, the handrail or the cable tray or the floor grating, FRP is non-conductive, so we don't have to deal with that isolation issue, which simplifies install but also reduces your maintenance long term. Now, hopefully we can run nice and quickly for this and be finished ahead of time, since we've run over time for the last few sessions. Another area of concern that we've identified is grating or decking fixings. Now, flooring fixings. Now, as we mentioned before, we've often got a mild steel structure that's got a coating system on it. If we use a self-drilling or self-tapping screw, obviously we're damaging that coating. It's very unlikely we'll be able to remediate that effectively on site within the confines of time and physical constraints, like lack of ability to blast and paint. We try and use a coal gal or something like that. So it's unlikely we'll get that coating reinstated to a satisfactory level in any case, or a bolt and nut. If we have the level of detail for floor grading before the structure is built, holes can be pre-drilled and then present when the coating's applied, whether it's hot dipped, whether it's a duplex system, whether it's got an epoxy or a paint spec on it. But often that flexibility from a timing perspective is not workable. So we developed these little items you see here as isolators. So we've designed the clamp system that eliminates damage to the coating. We don't have to drill, we're not putting a screw into it. We're simply clamping our floor grating product to the structure. So we clamp it to the web of a UB or UC, or to the leg of a channel. If we're using hollow sections, we might need to add some pleats or tabs to allow us to clamp to those. Excuse me. Allows us to clamp to those, but this allows us to use a stainless fixing or stainless clip from a durability perspective. Often we see far better durability by going to a stainless fixing, and the reason for that, in my experience, is where we've got a fixing, we might see some increased debris build-up, slurry, dropped object under a conveyor, ore and so on, build up, which will accelerate the corrosion of a fixing. If we typically go to a stainless fixing for better life, but that presents an issue with isolation. So we've designed these sleeves. Sorry, this, hindsight, this drawing probably doesn't clarify greatly, but if anyone wants more info, feel free to drop us an email. I'll have an email address shortly where we can be able to send you back some drawings where we use a stainless fixing and we clamp to the member supporting the grating, but then the clamp is isolated from the structure by a poly isolator which slips on very snugly onto the clamp, so it's not difficult to install. It's installed quickly and easily as a single operation, if you like. We're not trying to use rubber washers or something like that, but it makes a far quicker install, but also a lot more durable from the perspective that we're not scratching any sort of protective coating or damaging it. We're also keeping the stainless fixing isolated from the structure, whatever material that might be. That draws us to an end. Trust it's been a worthwhile discussion. Mark, if you could drop an email through hello@treadwellgroup.com.au, and anyone else as well, just drop an email through to this email address, hello@treadwellgroup.com.au, and we will flick you back some drawings and a couple of photos and so on of the isolator and the fixing clip combination together, so top and bottom clamp arrangement, just so you can get a bit of an idea of how they work. So anyone listening, feel free to drop us a note. Happy to be glad to get that back through to you. And I should also say, myself and the team are often out and about. If anyone would like to get a quick site walkthrough and a discussion, or maybe some advice on how to deal with some issues on your site, once again, drop us a note or give us a call, 1-800-246-800 in Australia, or 0800-244-600 in New Zealand. Always happy to have a discussion. Been able to finish this slightly earlier, which is nice for a change for everyone who joins, and we typically run overtime. But appreciate your support, and as I said, any feedback is welcome, good, bad, or ugly. If this was worthwhile, great. We'd love to know. If it wasn't worthwhile, we'd love to know that as well. And please feel free to send any topics that might come to mind through. Always looking for ideas and content. We want these sessions to be relevant to you all, so feel free to share them. It's 1:44 here in New South Wales where I am today, so stay on for another minute or so till it's 1:45. If anyone's got any other questions, feel free to put them on the Q&A chat. Otherwise, thanks for joining. Have a good rest of the day, and we'll talk soon. G'day, Stephen. How are you? Looks like that's everything coming through. We're always contactable. hello@treadwellgroup.com.au. Drop us a note, flick us some drawings. Happy to have a chat. Thanks for joining, and have a good rest of the day.